When a customer says my box is making a funny noise, it's important to understand what they mean. There are several possibilities. It could be the meter box, which houses the electric meter and connects the property to the utility grid. It might be the panel box, also known as the breaker box or electrical panel, which distributes electricity throughout the building via circuits. Or it could even be a plug box, which is the junction box containing electrical outlets. The key is to ask clarifying questions to pinpoint the exact location and component they are referring to. The phrase the box doesn't provide enough information for an electrician to diagnose the issue. Another common scenario involves the term tube. When a customer asks to fix their tube, they are often referring to a light bulb. The electrician needs to clarify if they mean a fluorescent tube, an incandescent bulb, or some other type of lighting fixture. A simple follow-up question like "what kind of light is it?" can help narrow down the problem. It is important to differentiate between a fluorescent tube, an LED bulb, or a traditional incandescent bulb because the repair or replacement methods will vary. The term wire is equally vague. When a customer says, "Is my wire broken?" the electrician needs more context. Which wire are they talking about? Is it the wire connected to an outlet, the wire running to a light fixture, or a wire in the attic? Without a specific location, it's impossible to diagnose the problem. It's just a wire is not descriptive enough. The electrician needs to know the wire's purpose and its location to properly assess the situation. It is important to know what the wire is feeding and its location to understand the circuits and potential issues. When a customer reports my outlet isn't working, the electrician needs to ask a series of questions to troubleshoot the issue. First, is the breaker tripped? A tripped breaker is a common cause of outlet failure. Second, have they tried a different appliance in the same outlet? This helps determine if the problem is with the outlet itself or with the appliance. Third, is the outlet physically damaged? A damaged outlet may need to be replaced. I don't know. It's not working is insufficient information. The electrician needs to gather more details to diagnose the problem effectively. Understanding the possible causes of an outlet malfunction allows for a more targeted approach to the repair. The electrical system has a breaker which may be tripped, or the outlet itself has failed. Effective communication is crucial for electricians. When dealing with customers who use vague or imprecise language, it's important to remain patient and ask clarifying questions. By carefully deciphering customer lingo, electricians can accurately diagnose problems and provide effective solutions. This ensures customer satisfaction and promotes a safe electrical environment. Understanding electrical terms is fundamental. Firstly, volts, which are the unit of electrical potential difference or electromotive force. It represents the electrical pressure that drives the flow of electrons in a circuit. Secondly, amperage, also referred to as amps, is the unit of electric current. It quantifies the rate at which electric charge flows through a circuit. Thirdly, ohms, which are the unit of electrical resistance. It measures the opposition to the flow of electric current in a circuit. Understanding these units and their relationships, as defined by Ohm's law, is essential for analyzing and troubleshooting electrical circuits. Let's discuss some common electrical components and their functions. Breakers are safety devices designed to protect electrical circuits from overcurrents. When the current exceeds the breaker's rated capacity, the breaker trips, interrupting the circuits and preventing damage to wiring and equipment. Outlets provide a convenient point of connection for electrical devices. They typically consist of 2 or 3 slots that accept the prongs of a plug. Wiring carries electrical current from the service panel to various points throughout the building. It is typically made of copper or aluminum and is insulated to prevent electrical shock. Now let's delve into troubleshooting techniques for common electrical problems. When an outlet isn't working, the first step is to check the breaker. If the breaker is tripped, reset it. If the breaker trips repeatedly, there may be a short circuit or an overloaded circuit. In this case, it is advised to consult a qualified electrician. If a light bulb doesn't work, firstly, check to ensure that the bulb is properly screwed in. Secondly, try replacing the bulb with a new one. If the new bulb also doesn't work, there may be a problem with the fixture or the wiring. If an appliance doesn't work, firstly, make sure that it is plugged in properly. Secondly, check the power cord for damage. Thirdly, try plugging the appliance into a different outlet. If the appliance still doesn't work, it may need to be repaired or replaced. Electrical safety is paramount. Always turn off the power at the breaker before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. Never work on electrical systems in wet or damp conditions. If unsure about how to perform an electrical task safely, consult a qualified electrician. Understanding the National Electrical Code (NEC) is crucial for electricians. The NEC provides a comprehensive set of guidelines for safe electrical installations. It covers topics such as wiring methods, overcurrent protection, grounding, and equipment installation. Staying up to date with the latest NEC requirements is essential for ensuring compliance and safety. NEC Table 310.15b16 details the allowable ampacities of insulated conductors rated up to and including 2000 volts. This table is critical for selecting the correct wire size for a given application to prevent overheating and fire hazards. Let's review some common electrical tools and equipment. Multimeters are used to measure voltage, current, and resistance. They are essential for troubleshooting electrical circuits. Wire strippers are used to remove insulation from electrical wires without damaging the conductor. Pliers are used for gripping, bending, and cutting wires. Screwdrivers are used to install and remove screws. Voltage testers are used to verify the presence of voltage in a circuit. When performing electrical work, it is important to follow proper procedures and techniques. Firstly, always turn off the power at the breaker before starting any work. Secondly, carefully inspect all wiring and components for damage. Thirdly, make sure that all connections are tight and secure. Fourthly, use the correct tools for the job. Fifthly, double-check all work before restoring power. Grounding is an important aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the breaker and preventing electrical shock. All electrical equipment and wiring should be properly grounded according to NEC requirements. Ground fault circuit interrupters (GFCIs) are designed to protect people from electrical shock. They monitor the current flowing in a circuit and quickly interrupt the power if a ground fault is detected. GFCIs are typically required in bathrooms, kitchens, and outdoor locations. Electrical panels distribute electricity throughout the building. They contain breakers that protect individual circuits from overcurrents. Electrical panels should be properly labeled to identify the circuits they serve. The panel should also have a directory that lists the location of each circuit. Over time, labeling wears off and some circuits could be mislabeled, which is why a directory helps find out what circuit goes to what. Lighting circuits provide illumination for various areas of the building. Lighting circuits should be properly sized to handle the load of the lighting fixtures. Dimmers can be used to control the brightness of lighting fixtures, saving energy and creating different moods. 277-volt lighting circuits are common in commercial buildings. Appliance circuits supply power to appliances such as refrigerators, stoves, and washing machines. Appliance circuits should be sized according to the appliance's power requirements. Dedicated circuits are often required for large appliances to prevent overloading the circuit. Large appliances like AC will take 208 volts or 240 volts dedicated circuits. When working with electrical systems, it's crucial to understand the different types of wiring methods. Non-metallic sheath cable, also known as Romex, is commonly used in residential wiring. It consists of insulated conductors enclosed in a plastic sheath. Electrical metallic tubing (EMT) is a rigid metal conduit that protects wiring from physical damage. Flexible metal conduit (FMC) is a flexible metal conduit that is used in locations where flexibility is required. In addition to understanding wiring methods, it's also important to be familiar with different types of electrical boxes. Junction boxes are used to enclose wire connections. Outlet boxes are used to mount outlets and switches. Ceiling boxes are used to mount lighting fixtures. All electrical boxes should be properly grounded. Electrical maintenance is essential for ensuring the safe and reliable operation of electrical systems. Regular inspections should be performed to identify potential problems. Breakers should be tested periodically to ensure that they are functioning properly. Wiring and connections should be checked for damage and corrosion. Lighting fixtures should be cleaned and maintained. Energy efficiency is an important consideration in modern electrical systems. Energy-efficient lighting fixtures, such as LED bulbs, can significantly reduce energy consumption. Smart thermostats can be used to control heating and cooling systems, saving energy and reducing utility bills. Energy audits can help identify areas where energy can be saved. When dealing with older electrical systems, it's important to be aware of potential hazards. Older wiring may be brittle and damaged. Older electrical panels may not have sufficient capacity to handle modern electrical loads. It may be necessary to upgrade older electrical systems to meet current safety standards. Electrical codes and standards are constantly evolving. Staying up to date with the latest codes and standards is essential for ensuring compliance and safety. Electricians should attend continuing education courses and read industry publications to stay informed. Troubleshooting electrical problems requires a systematic approach. Firstly, gather information about the problem. Secondly, identify the possible causes. Thirdly, test the possible causes. Fourthly, repair the problem. Fifthly, verify the repair. When dealing with electrical emergencies, it's important to act quickly and safely. Turn off the power at the breaker. Call a qualified electrician. Provide first aid if necessary. Electrical work should always be performed by qualified professionals. Attempting to perform electrical work without proper training and experience can be dangerous. Hire a licensed and insured electrician for all electrical work. Communicating effectively with customers is essential for building trust and ensuring customer satisfaction. Listen carefully to customer concerns. Explain technical issues in simple terms. Provide clear and concise explanations of the work that needs to be done. Answer customer questions thoroughly. Electrical estimating involves calculating the cost of electrical work. This includes the cost of materials, labor, and overhead. Accurate estimates are essential for winning bids and ensuring profitability. Electrical project management involves planning, organizing, and controlling electrical projects. This includes managing resources, tracking progress, and ensuring that projects are completed on time and within budget. Electrical business management involves running an electrical contracting business. This includes marketing, sales, finance, and operations. Effective business management is essential for success. Continuous learning is essential for electricians. Technology is constantly evolving, and new electrical products and techniques are always being developed. Electricians should attend continuing education courses, read industry publications, and network with other professionals to stay up to date.